We're going to go over the Module 2, Lesson 1 exit ticket now. I want to point out again, to go 1 kilometer is equal to 1,000 meters. So you're going to hear that over and over and over again. We also know that 1 meter is the same thing as 100 centimeters. And I just like having this here in the case that we are doing a lot of conversions. It's nice to just use this as a reminder to help us, because sometimes we get tricked up and we want to make sure we know exactly what each value is as we transition. So if kilometers, 71 kilometers, we know 1 is 1,000, so this would be 71,000 meters. In this case, I take away the thousands point, so this would be 30 kilometers or 30,000 meters. Meters to centimeters, so we know we increase by 100. So 81 times 100, would be 8,100. In this case, 400 centimeters would be the equivalent of 4 meters. If I wanted to convert this total into just meters, I know that kilometers turns into thousands, so 13,000 plus 20 would be 13,020. In this problem, I can go ahead and actually do it as 2 separate subtraction problems, I think. Let's see. Now, as I look at these place values, I want to point out that I'm noticing a few things. This is an entire singular amount. This is not separate from this. It's just not cashed out. And when I look at this, I'm checking to see, can I do this problem of 101 minus 153? I know I can't. The top number is less than the bottom. So if I borrow from here, that's the same thing as adding 10 here, or 1,000 meters. Now I can conquer the meters as well as the kilometers side of things. I may need to borrow, but that's okay. So in this case, borrow here, this becomes 11, becomes 10, this becomes 10, becomes 9, this becomes 11. 11 minus 3 is going to be 8 meters. 9 minus 5 is 4. 10 minus 1 is 9, and we don't have any leftovers in that thousands place that we would bump over. Now we can move over to kilometers. 10 minus 4 is 6. 9 minus 3 is 6. 3 minus nothing would be 3. So what we have here is 366 kilometers, 984 meters. I could always, if the directions gave me, give it as only meters. I couldn't give it as only kilometers since we wouldn't be able to exchange out those remaining meters. So the answer would be 366 kilometers, 948 meters. And I'll circle that for Mrs. Rogers' class. The last problem on this one, it says Gabe built a toy tower that measured 1 meter, 78 centimeters. After building some more, he measured it and it was 82 centimeters taller. How tall is his tower now? Draw a tape diagram to model the problem. Use a simplifying strategy or algorithm to solve. Write your answer as a statement. So I know that I had my initial height was 1 meter, 78 centimeters. I built onto it by 82 centimeters. So what I'm going to do is I'm going to do that 1 meter, 78 centimeters, 82 centimeters, and we're going to add up. In this case, 8 and 2 is going to be 10, carry the 1. 7 and 8 is going to be 15, plus 1, 16, carry the 1. So what I have now is 160 centimeters, 1 meter. That conversion tells me I can actually trade this 100 place value into the meters, which would leave me with 2 meters, 60 centimeters. You're going to hear in measurement a ton about simplification. What is the simplified place value it could be in, right? You're going to hear that. You're going to get used to it. So this conversion, you may do where you unbundle these larger amounts and then cash them back in. It may happen, and that is totally normal. So we know that Gabe's toy tower is a height of 2 meters, 60 centimeters.